Okay, dear students, so welcome in this video. In this video, we are going to learn about how to apply the principle of work energy theorem in gravitation. Bit confusing again, but please be attentive here, okay? And you can learn everything. Now, I told you that we are not considering the satellite motion as of now. We would be doing it in the later classes. But now, let us consider something else. Work energy theorem. So as we have done this thing in the topic A, at that time also, like you can go back and watch the videos again, I considered two cases. Number one, a case in which the total energy was constant, and the case number two, when the total energy was not constant. So let me explain you those things once again. Like point number one, when total energy was constant, and I told you at that time that work done by field force. I'm not talking about the external forces. There is no rocket, there is no engine here. There is gravity, which is the force created by the system itself. So I am only considering systematic forces, like we are not considering external forces. So if there is work done by the gravitational force here, that is found to be equal to the positive change in kinetic energy and the negative change in potential energy. So this formula I gave you in the topic A. So I'm bringing it back here and this is it. Now what is happening here? Take one example, like this is the pen. It is having some gravitational potential energy. Now it is getting attracted towards the center of the earth. It is falling. What is happening? It is losing some potential energy. This is converted into counter kinetic energy. The potential energy is lost, kinetic energy is gained. Okay, total energy remains constant, there is no change. Still, we will say that yes, work is done by the field force. The work done by field force can be found by either finding the change in kinetic energy or finding the change in potential energy. In both of the case, you can find the work done. But, but, in our case here, the problem is that we are considering cases when total energy is not constant. Either the total energy is lost or the total energy is gained. Like rocket motion is there and it is adding some energy into your rocket, it is adding some energy into your satellite, and there is increase in total energy. Or there might be that there is some kind of loss happening in the space, and the energy is lost somewhere because of any phenomena that can be cited here. Something happens and the energy is lost, so the total energy is not constant. Now, till now we considered these kind of cases and we said that kinetic energy in the first place is not even considered, so we will say that the change in kinetic energy is not happening. That was the condition that we put in the last video. So we are not increasing the kinetic energy, but there might be loss in potential energy, there might be gain in potential energy, but kinetic energy, we are not even considering that. Obviously, the total energy is not constant now. Why? Because total energy is sum total of potential energy and kinetic energy, but we are not considering kinetic energy. So if there is a loss in potential energy, the corresponding increase in kinetic energy is not visible. So total energy changes. Hence, this formula, which seems to be quite easy and applicable, that is not applicable in this scenario. But the another applicable formula is looking similar to this. I will show you this now. So we will define it here that work is equal to the change in total energy. Again, whatever it is, well, it could be external agency. Now I'm not writing work done by field force. It might be field force, it might be external agency, might be engine, might be rocket, might be anything. So work is equal to total change in total energy. So I will say what is the total energy final minus total energy initial. It will be potential energy plus kinetic energy final minus potential energy plus kinetic energy initial. Kinetic we are not considering, so at the end of the day we are having final potential energy minus initial potential energy, which is actually equal to the change in potential energy, which you can compare it with this, but there is nothing about kinetic energy. That is why usually people get confused in these work energy questions and work energy theorem and all. Like in some cases, this thing is valid, and in some other cases, this thing is not valid. Why is that? This is the reason. So work done here is equal to change in potential energy. If potential energy is increasing, like it is going from potential A to potential B, clearly potential A will be lesser because it is near, and potential B is going to be more because it is farther away from the center of the earth. So clearly, when the object is going from this point to this point, it is gaining potential energy. It is moving from more negative and it is going towards lesser negative value. So clearly, it is increasing its potential energy. And that is why it is positive, and work done is coming out to be positive. So work is done by external agency. So this is positive work, and in this case, work will be done by external agency. Now, why I'm saying that? Because gravity is definitely pulling it towards itself, but the body chooses to go otherwise. Clearly, the work done by gravitation force or work done by field force is negative because it is trying to attract the body, but the body is indeed going away from it. Clearly, the work done by field force or by gravitational force is definitely negative, but the magnitude is going to be same. So this is indeed coming out to be equal to negative potential energy, no doubt about it. So it is indeed coming out to be this, but it is not equal to kinetic energy corresponding. So this is different and this is different, but still we can say that work done by field is equal to negative of potential energy in this case. Work done by field force, but there is no kinetic energy. It is not related here, so do not get confused, and this is it. Now I am going to talk about potential and deriving a specific formula for you which will be used only in the gravitation. Okay, now let us say that the potential here is VA, potential here is VB. So we know that the formula for potential is negative GM by R, and the formula for the potential energy is negative GMM by R. We can clearly say it is the product of mass and the potential at that point. That's it. So work done by field force, it will be equal to negative of potential energy. So negative potential energy can be taken as m multiplied by change in potential. It will be negative mv final minus v initial. It is going to be this. So work done by field will be negative, and it is going to be vb minus va. Clearly vb is more than va, so this value will be positive, and because of this negative sign, the work done by gravitational field is coming out to be negative because gravitation is pulling it towards itself, but the body chooses to go otherwise. The body is going away from it. That is why this work done is negative. So work done by engine will be positive. So work done by engine we can say. So that will be positive. Change in potential energy. It will be again only the negative sign goes away. Every other thing remains the same. It is m into vb minus va, which is this. So this is work done by engine. So this is what is the work energy theorem applied to gravitation. So do not get confused. Be very particular about these things. Watch this video again and again. Try to solve as many questions from this topic as possible so that things they are very clear in your head. This is one of a very good topic, one of a very important topic, and difficult at the same time. Okay, dear students, so thanks for watching the video. This is Professor Varun. All the best.